All right, guys, today we're going to use absolute value functions and learn about transformations and also V translations, but this is a pretty awesome lesson, and I can't wait to show you some gestures tomorrow to make it even easier. Absolute value function, the parent function, or just the basic one, just the f of x equals absolute value of x, is always V-shaped. It's symmetric about the y-axis. And it starts at the origin here, and it basically goes 0, 0, 1, 1, 2, 2. It's like the identity line, 3, 3, 4, 4, 5, 5. And that's the reflection on this side, so it's a V-shape. The reason it does that, obviously, is because absolute value is positive, so the whole graph has to be above the y-axis to keep the whole thing positive. So really just two lines or rays beginning at the origin and making a V-shape. All right, a transformation. All the transformation does is it changes the graph size, shape, position, or orientation. So it kind of makes the graph shape changes, basically. A translation, another T word, is just a shift. It's going to shift the graph either left or right or up or down, but it really doesn't change the graph shape or the size or where it is. It just shifts it left or right. Big difference in the two. Transformation may make it, this is not math language, but may make it fatter or skinnier, whereas a translation just kind of shifts it around the coordinate plane. Okay, let's try one here and see what happens. Anytime you have numbers that are added or subtracted to your absolute value, your parent function, it's going to do the translations. It's going to shift your graph left or right. And what we're going to find out tomorrow is when the number is inside the absolute value, it's going to shift your graph left or right, opposite of what you think. If you have a number outside your absolute value, it's going to shift your graph up or down exactly like you think. I forgot the absolute value bars on this one. Remember this graph right here, the regular parent function, did this right here. It started at 0, 0, went through 1, 1, 2, 2. It was a line that went right through all the points that were equal right there. And negative 1, 1, negative 2, 2, V-shaped, symmetric, just like that. Now, what this graph is going to do with the plus 4 inside and the minus 2 outside is it's going to shift your graph 4 units to the left and 2 units down. So it's actually going to start the V right here, but it's going to be the same shape. It's not changing the shape or the size. It's just a shift. So it's the same graph that got shifted 4 to the left and 2 down. And if you want to see why, you could do this right here. You could make an XY table, and if I plug in 0 up here for x, I would get 2. If I plug in negative 1, I would get 1. If I plug in negative 2 up there, I would get 0. So you see what's happening. The graph is being shifted. Negative 3, plug in that, I would get negative 1. And these are exactly the points that are on that graph. So that's why the shift happens, because as you make an XY table, you can kind of see that it does. But tomorrow we're going to figure out really quickly that anytime you see one written like this, the number inside your absolute value is going to shift it left or right, opposite of what the sign says, and the number outside the absolute value is going to shift it up or down exactly like the sign says. All right, the next part, stretches or shrinks or reflections, and that's all about having a number in front of the absolute value. So if you see something like this where the number, you have an A, they're going to call it A, in front of the absolute value, it's going to either stretch it or shrink it. If it's less than 1, it's, like you would probably think, it's going to be vertically shrunk. And think about this. If you have a V shape and you shrink it or you compress it vertically, it's going to get fatter. It's going to get wider. If you stretch 1, if A is bigger than 1, if the absolute value of A is bigger than 1, it gets stretched. And if you take a V and stretch it, it's obviously going to get much steeper or thinner. And the last thing, if A is negative, if you have a negative in the front, it's going to reflect it across or in the x-axis, which means your V, instead of going up, is going to go down. So let's look at all 3 of those real quickly. All right, let's look at a couple here. This first one has a 1/2 for the A in the front, which means it's going to be a vertical compress, or it's going to shrink the graph. There's nothing added or subtracted to the x, so it's going to be started 0, 0 again. And all it does is it changes the slope of your V. It's going to make your V flatter. So I'm going to, instead of going up 1 over 1, I'm going to go rise 1, run 2. Missed that one. Rise 1, run 2. Rise 1, run 2. Over here, same thing on this side. And then when you draw your V, it's a lot. It's basically half as steep as what it was. The second one here has a negative 3 in the front. What the negative 3 is going to do is it has 2 things that's going to happen. One is it is there's no shift, so it's going to start at 0, 0. Nothing added or subtracted, but the 3 is going to stretch it, which is going to make it steeper. The negative is going to reflect it across the x. So what's going to happen on this one is, if it was positive 3, I'd go up 3 over 1. Because it's negative 3, I'm going down 3 over 1. Down 3 over, I hope you can see those green dots. Down 3 over 1. Down 3 over 1. And just connect those. And there's your v. So that's pretty good visual of what happens. If you have a fraction less than 1 in front, it shrinks it, which makes your graph much fatter. If you got a number bigger than 1, absolute value bigger than 1, in the front of your absolute value, it makes your graph much steeper or skinnier. And the negative, of course, reflects it across the x. It turns it upside down. All right, we're going to try one here that has everything in it. Has the numbers added or subtracted, has transformations, and has translations. The whole deal. It can't get any worse than this. This has everything. Always start first with your translations or your shifts. So I have an x minus 1, which is going to shift at right 1, and I have a plus 3 on the outside, which shifts it up 3. So I'm going to go right 1 over up 3, and I'm right there. That's my new vertex. That's my new 0, 0. And so from there, I'm going to use the 2 in the front. Usually that means I'd go up 2 over 1, but because it's negative 2, I'm going to reflect it down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And then just connect those dots. La, la, la. And there's your V. That's all we're doing. All right, so if you can do that last one, if you see that last one and you get that pretty good, that's all of it. I mean, that's everything that we did today, translations and transformations, and I got great gestures for you tomorrow. It's going to be so easy once you see them, and can't wait to see them. So, see you, bye.